Imagine the world around you slowly fading away. You can always choose to open your eyes again. However, if you become blind, darkness is all there is. Blindness is one of the worst disabilities. It excludes 40 million people worldwide from participating in most parts of social and economic life. However, there is hope. ReVision Implant is developing Occular, a breakthrough visual prosthesis. Occular is an all-in-one solution to restore practically useful vision. Occular consists of two parts, an external part that looks like a pair of glasses and a part that is implanted in the back of the head. The front side of the glasses contains a small video camera to capture whatever the user is looking at. The side of the glasses contains a battery and electronics to convert the video stream into stimulation patterns that the brain can understand. The back side contains an antenna to transfer power and data to the internal part. Now, let's take a look at the implant, which is buried in the skull, invisibly under the skin. Its electronics receive the signal and control over 1,000 electrodes that are inserted in the visual cortex of the brain. These microelectrodes are the most important part of the implant. They directly interface with the brain's natural circuits through small electrical pulses. They are shaped like tiny little wires and are extremely thin, having a thickness similar to a single nerve cell. By placing the electrodes closely to the neurons of the brain, only a few tens of microamperes are needed to produce visual sensations, and a high resolution can be obtained. The implant works thanks to a property called retinotopy. This means that a stimulus in one spot of the visual cortex of the brain causes you to view a dot in a well-defined location in your field of view. With multiple stimulation points, you can create shapes and even images. With thousands of stimulation points, useful video can be transmitted directly to the brain, even if the eyes or the optic nerve are completely dysfunctional. So, as earlier visual prostheses offered only disappointing performance, where are we making a difference? And how can we target a 100-fold improvement? First, unlike earlier implants that were put in the eye, Occular is implanted in the primary visual cortex of the brain. There, a much larger area of sensitive tissue is available for stimulation, drastically improving potential resolution. Second, we are implanting thousands of microelectrodes to obtain high resolution. Third, these electrodes are placed on flexible strands no thicker than a single cell, drastically reducing irritation and scar tissue formation. Fourth, we have developed an insertion mechanism to put these strands in the brain with minimal damage to the surrounding tissue. On top of that, we use advanced stimulation patterns that create virtual electrodes, enhancing resolution beyond the number of electrodes that are physically present. And finally, our electrodes can be implanted in areas needed for both peripheral and central vision, restoring a more natural viewing experience. By combining all these factors, we at ReVision Implant work on a direly needed breakthrough for restoring practically useful vision.